understanding this trade of helps decide when the model fails and when they shine. So now going to the non-parametric machine learning algorithms. Non-parametric machine learning algorithm means the model does not assume. So it does not assume linearity, Gaussian distribution, independent of features, and fixed boundaries. So instead, the model says, let the data speak for itself. So the model becomes more flexible and adapts to whatever shape the data forms. So real world analogy, let us see an example. Imagine sculpting clay. Clay has no fixed shape. It can be molded into anything. So similarly, non-parametric models can mold themselves into curves, clusters, complex boundaries, irregular shapes, etc. depending entirely on the training data. So that's why the non-parametric machine learning models are very popular, and it has few machine learning algorithms like K nearest neighbors, decision trees, SVM like support vector machines likewise, and kernel density estimation like a few popular non-parametric machine learning algorithms are there. So the key characteristics of those non-parametric models are they are highly flexible, no fixed number of parameters, and it grow in complexity as data increases, capture non-linear relationships, and very powerful with large data sets. These properties can make them excellent for real world problems where patterns are unpredictable. So the following benefits and limitations of non-parametric machine learning algorithms. First one is flexibility. So extreme flexibility it has. They can represent anything from simple line, complex spirals, multiple clusters, non-linear boundaries, etc. And very few assumptions it has, and as there is very few assumption, the power consumption is low and about the underlying function, and performance wise it can result in higher performance models for prediction. So it is highly accurate in complex data sets, fraud detection, medical diagnosis, customer segmentation, as well as image classification. And while coming to the limitations, it requires more number of data because the training data should be more to estimate the mapping function, and a lot slower to train as they have far more parameters to train. As also KNN needs many points for good accuracy and all, and the overfitting. As the training data is more and it is harder to explain why specific predictions are made, that overfitting risk comes because the model adapts too closely. It might learn noise, outliners, and unnecessary details and all. This reduces performance on new data. So choosing between parametric and non-parametric depends upon the data size, model complexity, computational power, requirement of interpretability, nature of patterns in the data. So this decision alone can dramatically impact model performance. Now coming to the theory. So this is the central pillar of Bayesian Decision Theory. Let us see about some real life examples. First one could be doctors predicting diseases. We all are familiar about it. Then bank predicting lone defaults, and AI predicting whether a driver may crash or what, email filter prediction system, and face recognition predicting identity. So the world is uncertain and the AI must make decision with that uncertainty, not against it. This is where Bayes theorem and Bayesian decision theory came into play. So it's a framework that combines probability, how likely something is, cost of decisions, consequences of being right or wrong. It helps us answer which decision minimizes the risk, which class is most likely correct, how confident am I in this prediction. Components used is priors, which means initial beliefs, and then likelihood, how data fits the class, and then evidence, overall probability of data, and posterior updated belief after data, loss function, cost of decision, probability decision density function PDFs, probability mass functions PMFs. Using these components, Bayesian classification chooses the class with the highest posterior probability, and this gives the most mathematically rational decision in the presence of uncertainty. And random variable and Bayes theorem is to understand the Bayes decision theory. So before going to that, we'll see about the prerequisite needed for this Bayesian decision theory.